What's up, everybody? Welcome back to another live stream from Scalar Learning. We're doing 2 today. Now, let's jump straight into SAT Math. We're doing Khan Academy problems straight from the source of Khan Academy. And today we're tackling inference problems. So, without further ado, let's get into it. Now, again, I'm seeing these problems for the first time. I haven't seen them before, so that's part of the fun. And it's also the best, most authentic way to give you a true experience of what it's like to take these in real time. Here we go. A random sample of 500 residents in a town included 173 who primarily spoke a language other than English, with a margin of error of 25, the confidence level of 98%. Confidence level. Okay. If the town has, so we took a sample and we got 173 out of 500. This is a calculator. By the way, if the town has 25,000, this is number of residents. This is spoke other than English. If the town has 25,000 total residents, I'm immediately setting up a ratio like this. How many residents primarily speak a language other than English? So this is spoke other, right? And that's what we're solving for with a 98% confidence level. So again, we've got to apply that same margin of error. Boom, cross multiply, 500x equals 173 times 25,000. 173 25. Just 4325. And then we divide both sides by 500. It's like dividing that by 5, but we'll just divide this by 500. Oops. Come on. 8,650. So we know that's the main value, but then it's a margin of error of 25 residents. See, I think this is fooling us because it's not 8,000. We don't subtract and add 25, right? Here's what I think we do. I think we have to scale up the margin of error because that's a margin of error within this pocket, right? So what that means is if this is 25,000, we have to say 500 over 25,000 equals 173 over x, and that's going to give us the proper margin of error. This is just what makes sense to me. I haven't seen one of these like this before. 173 times 25,000. Oh, equals that number 4325000. And then we divide both sides by 500. Wait, just got that number. Hold on a second. Oh, what am I doing? I did the wrong number. It should be 25 up here. Sorry, so that's the margin of error. So 25 times 25,000 to 500x equals 25 times 25,000 equals 625,000. And then we divide both sides by 500. It's like dividing by 1,000, then doubling. 1,250. So x equals a margin of error of 1,250. So I'm going to say the bottom range is 1,250 minus this, or that minus 1,250, which is 7,400. The top range is 1,250 plus this, which is 9,900. And so I'm going with A. Let's see if it's right. Yeah. So we got to remember to scale up the margin of error in addition to, the real deal. Next, in the National Health and Nutrition Examination Survey, 80.5% of the participants had healthy levels of this. The estimate has a margin of error of 1.5%. The participants were a random sample of the United States. If the United States population was 316 million, confidence same number, who had healthy levels of HCl. So this is what we do. We take 8.80. Actually, sorry. Let's just go ahead and use the margin of error. This is easier. So 80.5 with a margin of error of 1.5, meaning at its low end, we subtract 1.5, which is 79%. At its high end, we add 1.5, so 82%. So it's 82% and 79% of the 316. So 0.79 equals 249.64. And then this is 0.82, which is 259.12. So I'm feeling like our answer's in there. And if we round this up to 250, round it down to 259, I say this is golden. Boom. Next. After randomly sampling 1,000 cars, determine 95% confidence level that the mean time needed to wash a car is 8 minutes and 56 seconds, which with a margin of error of 7 seconds, which could be the bounds of a 90% confidence interval based on the same sample. So look, all right, we don't have to, I don't think we have to actually calculate this. So like with 7 seconds, it's 8:49 and it's 9:03, okay? This is the current range with a 95%. If we're 90% confident, that range, it only makes sense, is going to get smaller, right? Because we're going to be less confident. So here we're like, hey, we're pretty sure we got this this within the range. The mean is within this range. So maybe I'm thinking like, I don't know, 8:52 to 9 minutes, just like a random guess. And see, this is out because, no. Yeah, this is like a bigger gap. That's like 29 seconds versus here we've got a 14-second gap. So it should be smaller than 14 seconds. This is a 15-second gap up top. 25. And look at this. Here we go. This is the only one that shrinks the gap, right? That's 10 seconds instead of 14 seconds. So I'm going with D because we're less confident, and that's it. Must be inside the, right, 95% confidence interval. That's it. Next, an archaeologist uses accelerator mass spectrometer to find the age, whatever. At 68%, the spectrometer estimates that it was 10,000 with a margin of error of 200. So 9,800 on the bottom, 10,200 on the top. Which of the following could estimate the age at a 95% confidence level? So right now we got a spread of 400. Now, if we're talking about 95%, right, we need to widen this substantially. It's got to be bigger than 400, right? 95 with a margin of error of 5. So it's at least a bigger margin of error. So that looks good. Actually, it's the only one that works, right? Because, no, this could also work because it's a bigger margin of error, right? 400. So that means we go from 10,400 to 9,600. I feel like it has to be B, not A, because like I don't think we actually have to do the math to verify, but I think that it should still center at the same spot. We should still be at 10,000, but then just broaden the scope. This actually moves it. So then 10,000 is at the top, 9,000 at the bottom. So I'm liking B. This one is too small and this one is too small, right? These are actually smaller than 200. So 95% confidence should get bigger, and it's correct. See, only the margin of error, not the estimated age, would change. So that's why that mean value of 10,000 or whatever, the value of 10,000 should stay constant. Again, this is more my logic kicking in when I'm answering these. Okay, next. A random sample of 500 residents include. Hey, this is the same question as before. Look, 500 residents of a town included this who spoke a language other than English with a margin of error of 25 residents and blah blah blah. 25,000. Okay, so I remember this was the answer. This is just the first question that we got. It repeated, and there we go. All right, so that is it for the explanations. Hope you guys enjoyed that. Hope you found it helpful. If you did, please click that like button. And if you want to see more from the Scalar Learning channel, where we make standardized test prep our mission in the math department, make sure to click that subscribe button. We got a bunch of other cool stuff coming out on a regular basis. Also check in for ACT stuff, IC stuff, etc. Thank you guys so much for joining, and I'll see you all next time. Take it easy.